So the next one I want to look at is the 2014 exam. This is paper 2 and it's question 13. And the question you see is what I want you to have a look at. Pause the video if you want to attempt the question, but it was one of the more difficult ones. So I'm going to have a look at it. So you see this shape and it asks you to calculate the area of the cross section of the tunnel. Now the cross section is this shape, this one. And you might be thinking, well, I didn't learn how to calculate the area of these types of shapes. And to an extent, you're right. But if you look at it, you can see two other shapes that you do know how to calculate the area of. Because if I draw this, you have this. I'm not the best artist, but as long as you get the picture, you get this, you get 1 and 2. Now, number 1 is a sector, and number 2 is a triangle, both of which you learn how to calculate the area of in National 5 Maths. Now we'll first of all have a look at number 1, which is the sector. And we'll go down here, and this is the sector. I have the formula on this slide for the area of a sector. So that's pi r squared times A divided by 360, and A is the angle at the centre. So in red, that is the formula for the area of a sector. Now, we need to know the angle, but the question tells us that this angle is 50. So this is 50. And we need to then find the relevant angle to substitute into the formula. But the angle we need is the one inside the sector. It's this one. So that's going to be 360 take away 50 is 310. So that is 310. And we're going to first of all calculate the area of the sector. So we have the formula, and we're going to write the formula down and then substitute the values in. So area 1. So area 1 is the sector. And our A is 310. So we can hide the slide with the formula. Sorry, got that. So we're going to put 310 times pi. It's a calculator exam, so we don't have to evaluate pi. You just put pi into the calculator. The radius is, in the question it says, if you look at the 4th bullet point, the radius is 7 meters. So we're going to multiply by 7 squared divided by 360. Now, you won't be given this formula in the exam, so you need to learn it. And if we then substitute the values and input it into the calculator, we get 132 point. You want to keep at least 2 decimal places in this one, so but I'm going to keep 3 just in case. I'm going to put 5. So to be safe, we're going to put 558. A common mistake that many students make is rounding prematurely. What that means is, for example, if I put 133 at the minute and I rounded it, that's rounding too early. You need to keep all of the decimal places, or at least 3 decimal places we're going to keep. And I will show you at the end why that's an issue. It will affect the final answer. So our units in the question are meters. So the area is in square meters. So that's meters squared. So that is the area of the sector. If we go back up, we then have the triangle. But the triangle is not right angled, so we can't use the basic formula that you learned in S1, S2, which is half times base times the height. We're going to use this one instead. So this is the formula. I will make this larger. So it's 1/2 AB sine of C. And what we mean by that is, if you look at the image, this shows what we mean by A, B, and C. So small a, so the small letters signify the sides. The capitals signify the angles, and the capital B is the angle capital B is the angle opposite the side B. Angle C is opposite side C, and so on. So we have A, B, we have 1/2 multiplied by A, the side length, B, the side length, and angle C. Angle C is in between the sides A and B, so we need the angle to be in between the two sides. So let's have a look at the question. We have this, and this side is 7 meters, so we can write 7 meters. This one's also 7, and the angle in between is 50. That's 50 degrees. So we have the necessary information to calculate the area. Suppose, for instance, we didn't have that angle, but we had this one indicated in blue. This would be wrong, because it has to be the angle in between the two sides which you know the length of. So our formula for this one is going to call this area 2. Equals 1/2 AB sine C. That's 1/2 A B sine of C. So A is they're both 7, so we can put 1/2 times 7 times 7 times the sine of 50. Do not put 50 because it's the sine of 50. You would get a grossly incorrect answer if you put 50. And you're going to substitute this in, and again, we want to keep 3 decimal places, which I think is more than what the SQA require at the moment, but you want to err on the side of caution, so I'm going to substitute that in to the calculator. We get 0.5 times 7 times 7 times the sine of 50, and that is, we will use 18.768. Again, the units are meters squared. So we've calculated area 1 and area 2. So the final answer is going to be the two areas added up, because you see it's a compound shape, so you need to add both of them. So I will go back down and we'll write down the total. So the total area equals and be sure to explain in the question exactly what it is you're doing. Like, as I've shown the diagrams, the best way for the examiner to know your exact logical steps, would be to show these diagrams so they know which shape is which. So you label them 1 and 2. You can do this many ways, but I think the easiest way is label this 1 and find 1, then find 2, and the total is, so 1 is 132.558. 132.558 plus area 2 is 18.768. Plug these in, because again it's a calculator exam, and we'll plug these in, and again we will retain 3 significant figures. That is 151.326. I'm going to keep, this is a matter of personal choice, but I think 4 significant figures is enough. So to 4SF is 4 significant figures. We have 151.3, and that's us done. So I'm going to get the marking scheme up, and we're going to look at how the SQA would assign marks to this question. because there's a lot of logic marks. Some of the marks in this question are for common sense. Some of them are easy to get. It's just following logical steps. Some of them are a bit more difficult, but you do get the formula for the area of the triangle in the sheet in the exam. And if we go up, I can show you this. There we go. It's underlined. It's 1/2 AB sine C, so you don't have to learn that, but you do need to know how to use it. And I will get the question up. So the first step would be for knowing to split the shape up. So that's the first mark. Know how to find the area of the segment. So something like this, and evidence of at least attempting to calculate the first area, then the second area, then adding them. Even if the maths is wrong, just knowing to do that gets you 1 mark. Then knowing to express the fraction. So the next part is finding the fraction of the circle. So this here would be 310 over 360. So we have, this is the second mark. And if I highlight it in green, this would be this and this. But they're embedded in the formula. So the third mark is for knowing how to find the area of the sector. So this would get you the third mark. This here. The fourth mark is for finding the area of the triangle, or knowing how to do it. Oddly enough, if you have a look at the marking, the areas are in brackets, so you don't get the marks directly for this, but you will get the marks at the end. So you don't even have to get the answers 132.56 and 21.38 or 18.77. You don't have to get those in order to get marks 3 and 4, but you will need these at the end, and the final mark is for the answer. And if we want to have a look at this, these are the ways in which people have lost marks. So you can use 3.14, you can use 22 over 7, but the best way to do it is substitute pi into the calculator. And you have to, as a word of warning, you have to make sure that the calculator is on degrees, because until you get to higher, you don't need to know how to use radians. That's above your level, but you will lose at least 1 mark per paper if you do not switch your calculator to degrees. At Nat 5, you just have to worry about degrees. And this is a list of the many ways that people lost marks. So if you want to, again, pause the video and have a look at these, you can do that. But yeah, that one was definitely one of the more difficult ones, and that makes sense because it's the last question of the paper. But I hope you found this video useful, and best of luck.